Alright, we're going to be talking about the volume of pyramids and cones. We were talking about the volume of prisms and cylinders, but today will be pyramids and cones. Now, if you look at the middle picture here at the bottom, this is a cube. And if I were to divide this cube, I could create three congruent square pyramids. So you have this one here, this one to the right, and this one to the left. What that means is that when you look at the formula, it's going to be 1/3 the area of the base times the height. So we would be able to find the area of the base with length times width in the case of a square, or length times width in the case of a rectangle. If it's a triangular prism, you would have 1/2 base times height to find the area of the base. Then I would multiply that by the height of the pyramid and by 1/3 to get the volume. So let's go ahead and find the volume of this rectangular pyramid. What I would do first and foremost is draw a picture. So I'm going to do that right now. Alright, so what you've seen me do here is create the rectangular pyramid, and I've put in the length of 11, width of 18, and the height of 23. So the first thing I need to do is find the area of the base. So I would do 11 times 18 to find the area of the rectangle. Alright, so once I have the area of the rectangle, I then need to take it, multiply it by 1/3, and multiply it by the height to find the volume. Alright, so don't forget to put your units here. It's really important that you put the meters cubed. Remember that volume is cubed while area is squared. Alright, so in this next picture it says find the volume of the square pyramid with the base edge length of 9 and a height of 14. Now because it's a square base, I know that all the sides are the same length. So if a side length is 9, it has to be 9 all the way around. So the first step would be to find the area of the square, which is the base of my pyramid. Once you have the area of the base, all you need to do is plug it back into the formula, 1/3 times the area of the base times 14. And we got 14 because 14 was the height. So that would be 378 centimeters cubed. Again, be very careful about your units, okay? You need to make sure that you are cubing when you talk about volume. Alright, so as a refresher, let's go ahead and talk about the apothem. You remember that the apothem is a perpendicular line to one of the sides of your shape, and it connects to the center. So what we have here is the center. This is the perpendicular where it crosses with the side. Okay? So that green line that we see here is our apothem. Now, remember that regular polygons have all congruent sides and all congruent angles, and that the area of a polygon is 1/2 times the apothem times the perimeter. So you're wondering, why are we discussing this? Okay? Here's why. A pyramid can have any type of base. It could have a square base, a triangular base, a rectangular base, or in the case of the problem that we're about to do, it's going to have a hexagonal base, which means it has a hexagon for its base. So as a practice, what I'd like for you to do is pause and find the area of the polygon, the regular hexagon shown here. Okay? So go ahead and take a minute and pause and try it now. Alright, so make sure that you've done your work correctly. Tangent of 30 equals 6 over a. You get 6 because it's half of 12. Okay, 360 divided by the 6 sides gives me 60 degrees, but I cut it in half to find the angle measure right here. Okay, so finding the apothem, I get 10.4 feet. To find the perimeter, I do 6 sides times 12 feet gives me 72 feet. Plug it into 1/2 times the apothem times the perimeter, and you get the area of 374.4 feet squared. So what this means for us is that we can now find the volume of the pyramid that we did here. Remember that the volume of a pyramid is 1/3 times the area of the base times the height. So we just found the area of the base in the previous problem, 374.4 feet squared. Okay, so in the volume formula we have 1/3 times the area of the base times the height. So now the question is what is the height? In the problem, it did not give us a numerical value for the apothem. However, it says with a height equal to the apothem of the base. So we actually found the apothem to be 10.4 feet. So the volume is going to be equal to 1/3 times the height, or excuse me, times the area of the base, which is 374.4, and then times the height. Well, the height was just the apothem according to the directions. So our apothem was 10.4. And then we will type this in our calculator for our solution. All right, so that remember that volume is cubed units. All right, so what we have here is basically a pyramid, but with a circle for the base. So the formula is still 1/3 times the area of the base times the height, but we already know that the area of the base is going to be pi r squared because my area of a circle is pi r squared. So this and this are the same thing. So let's do a practice example. Find the volume of a cone with a radius of 7 centimeters and a height of 15. Give your answers both in terms of pi and rounded to the nearest tenth. Alright, so the first thing we need to do is find the area of the base. And the area of the base is pi r squared because it's a circle. We're given that the radius is 7. So that would be 49 pi is the area of the base, and that would be centimeters squared. Now volume is going to be 1/3 49 pi times 15. So volume equals 1/3 times the 49 pi times the height of 15. And what I'm going to get here is 245 pi centimeters cubed. All I had to do was type that into my calculator. Now here's what's really important is that it also says to give it in terms of pi and round to the nearest tenth. So you'll hit that double arrow button directly above enter once you get 245 pi. And what you should get is approximately 769.7 centimeters cubed. That would be the rounded solution. Alright, find the volume of a cone with a base circumference of 25 pi inches and a height of 2 inches. Now the problem is that we need the radius in order to find the area of the base, and we're not given the radius. However, we are given that the circumference is 25 pi. So if circumference equals 2 pi r, I would take this 25 pi and plug it in for circumference. So 25 pi equals 2 pi r. When I divide both sides by 2 pi, the 2's simplify to 1, the pi's simplify to 1, I'm left with r equals, oops, I forgot my 2 right there, 25 over 2, which is 12.5. So I have a radius of 12.5 inches. And I have a height of 2 inches. I can now find the volume of the cone. So the volume equals 1/3 pi r squared, r is 12.5, times the height, which was 2 inches. So volume equals 625 pi over 6, or as a decimal, 327.2. And then don't forget your units, I should have put them here, inches cubed. So instead of finding the area of the base first and foremost, I just went ahead and plugged the radius in directly into the equation. So you could have found the area of the base first with pi times 12.5 squared, and then plug that number in, or you could have just plugged it in how I did here. Now, occasionally when we work on problems, I'm going to skip this one actually, and that one. Here's the problem I wanted to work on. All right, so occasionally we're going to have something like this figure here, where there's multiple objects, multiple shapes attached to each other, and we call this a composite figure. So what I have here are two cones attached to a cylinder. Okay, so this would be like a pencil that you've sharpened on both ends. So the first thing we have here is this cone. Then I have a cylinder followed by another cone. So we need to find the volume of all three objects. Alright, so on the bottom figure, we've been given a radius of 21 and a height of 40. So plugging that in, the volume of the bottom cone is 5,880 pi centimeters squared. Okay, now we are given that the height of the cylinder is 35 with a radius still of 21. So to find the volume of a cylinder, all you have to do is the area of the base, which is pi times 21 squared, times the height, which is 35. So the volume of the cylinder is 15,435 pi centimeters cubed. And I'm leaving it all in pi because I want to round at the very end, because what I'm going to have to do is I'm going to have to add all of the volumes. So this right here is going to be the cylinder. Over here we have the bottom cone. And then our next job is to find the area of the top cone. So in order to find the area of the top cone, we would need to find this height. However, we're not given precisely that information. We're given that from the tip of the cone to the bottom of the cylinder is 75. We already know that from here to here is 35. That means the height of the top cone is 35. So the volume is going to be 1/3 pi times radius squared times height of 35. So the volume of the top cone is going to be 5,145 pi centimeters cubed. Now what I need to do is I need to take all three of these volumes and add them together to get the composite figure. So when I add all three of those, I get 26,460 pi centimeters cubed. So weird looking at. Alright, so then I need to type it into my calculator to see what it will be as a decimal. And I get approximately 83,126 and it says round to the nearest tenth, so 0.5 and centimeters cubed. Alright, that's it for today. Thank you for watching.